My goal is to talk about the observations that I've had from my past through my career and my life, and how those may have an effect on how you think about learning. It doesn't come from basic research. It doesn't come from any deep core educational academic learning. It comes more from the other side, what I'll call the pull from how do you accomplish something. And I'll show you some of my background that's relevant to that. First thing I'm going to say is, and this is a chart, and it's a warning, but I've had this chart for a long time. Your brain forms a perception of the future in the same way it perceives the present. I got news for you. Your future isn't what you think it is, because with the rapid change that's happening in the future, what you think you see is an illusion. What's important, and this is what needs to be taught, is that your ideas and your thoughts can be turned into visions and actions. And that's what you need to understand, is it's valuable what you think. And I tell a lot of people, crazy ideas, unrealized thoughts, whatever that may be, you need to understand that you need to share those ideas. The solution is, and I'll show what I call transformational questions. Questions that change the way we think. The objective is to build teams and communities that all think this way, and to have them share it in the right kind of an environment of sharing crazy ideas, if you want to look at it that way. The methodology is we've got to figure out how to help people change paradigms, mindsets, what they see for the future. You'll see in a moment, I've grown up in an environment where what we've got to do is think about what people have not thought of before in order to enable change. And that's what students, that's what teachers, that's what needs everybody to understand, that they need to be able to share these kinds of transformational questions. What do you get for a return on imagination? By the way, you probably won't find it anywhere on the internet. But what you do is you start understanding the trends that are happening, where we're going. You start understanding that there are patterns that are happening in life, and that you can adjust those patterns, and you can have a definite effect on things that you may not realize. And I'll talk about what I call cross-domain knowledge here later, which basically said changes many times come not from the subject matter experts, but they come from the non-subject matter experts, people that don't know what you're really trying to do. And what you want to do is you want to figure out how to capture those ideas and those vectors in order to have a change in the future and affect the visions of the future. So what I want to talk about first is my thinking outside the future. And this is kind of a summary of where I am. You know, I started by launching the only thing that's ever left the solar system. It's called the Voyager mission. So we're talking 50 years ago, who would have thought that we would have ever launched anything that now is in deep space and is heading for some ET to find along the way? Because there's a message on it. I've also been a part of building probably one of the most critical aspects of changing our future, which is the shuttle program. I was a part of that. And what you see today is what they call the growth of the low Earth orbit economy. And the low Earth orbit economy is a place where you're going to live, play, and work, and people will exist in normal environments. Who would have thought that, 50, 60 years ago? So it's the idea of how do you dream about the future? I was a part of a couple of satellite missions, because I worked at NASA, where we were doing wind polar satellites, chemistry. We were measuring the health of the Earth. We were actually starting back then, and we're talking decades ago, trying to want to understand the future of the Earth and where it's going, and what's happening to it. And the scientists I had to work with basically were dreaming what could they develop for instruments in order to accomplish that vision. I was a part of working, I actually did programming on computers that were probably twice the size of this room and used water to cool it. And I was also part of the world of building the first workstations that became the laptops of the future. The transition, in fact, I'll tell you, I started college like where you guys are now with a slide rule. And from there, I've learned a lot. I was a part of a national program called Digital Earth, which was a vice presidential initiative. And it was the idea of how do you get everybody to fairly share information? And I know you'll like this one. But the world was, how do we take this growth that's happening on the internet and data? And this is long before Google and everything else you guys go after. How do we create an environment in the future where people can share information? I've been a part of launching missions that actually have looked back in time. The mission was called Janus, and what we did was we were building instruments that were going to look for the very first stars of the universe. That is, when the universe used to be a cloud when it first started, and that first stars formed, and there was the first light. And that first light we were looking for to understand where we were heading in the future. I've been a part of a large project with NASA, an education project. In fact, NASA's largest education project. And the goal was, how do you figure out how to affect the future of the mindsets of the youth of the future, such that you can share the information that NASA has today? I'm not going to go through all these. And the last one was, I've been a part of the AI community. I actually work for AI companies. And one of my function was to convince them that they need to go from a garage shop. In other words, if you think of Apple Computer and Microsoft, they basically started in a garage, and look where they are today. Well, that's kind of what's happening with AI along the way. It used to be a garage shop, and now it's becoming mainstream. But what I want to share with you is the thoughts that we need to create in our learning environment. That's where I'm headed based on this. First thing I'm going to share, that's observational, is this chart. Now, I'm sure you've never seen it because I created it a few years ago. Innovation Index, and it's the idea of how do we look at the future and the changes that exist. Most of our world is based on this idea of just making things better, updating it, enhancing it, or even making it unique. And that's what I've come to call outside the box, because outside the box really doesn't change the future. It's really just trying to improve what we have. My goal is, how do we think outside the future? Now you know where the title came from. And that comes because of disruptive and discontinuous activities, technologies, whatever it might say. Discontinuous or disruptive is basically you got to change the rules. For example, when I don't know why they have that up there at the top, but smartphones, 3D printing, AI are examples. If you can do it, that'd be nice. Probably just a mouse. Smartphone, 3D printing, AI is really just examples of disruptive. You have to change the rules of how you do work, is what it comes down to. But examples, that was good, except now I don't work. Yeah. Huh. I can put up with it there. There. Examples of this, thank you. Examples of discontinuous is things like the automobile and the computer. Basically, it says you got to throw away the rules, and you got to start all over. You can't just modify the rules. Are you okay? Yep, I'm good. And my goal is to introduce, that's okay. I don't do much at the top, so it'll be fine.
All right, sorry.
So my goal is to talk about changing the future by thinking outside the future in these kinds of contexts. How do we, well, actually, it's going to keep going back. Doesn't matter, it'll live there. How do we see these alternate futures? So what I'm going to propose is the first thing we got to do is ask the right questions. You know, we're taught throughout entire life that we're rewarded for asking or for answering the right question. In reality, I propose that we need to reinforce through learning asking the right question, not answering the right question. And that we need to seek what I call root questions that drive this discontinuous, disruptive future. And we need to teach people not to be afraid to ask those root questions along the way. We all have the ability to change the future. I'm going to tell you, no matter who you are and no matter what your discipline is. In fact, I found myself in amongst a lot of scientists as I was building instruments for deep space exploration, and I had the foggiest idea what that science was. But I found that I could ask questions because I wasn't an expert, and I would actually drive change because I asked perhaps questions that was unbiased, and I asked questions that were perhaps not perceived as being dumb or stupid because maybe, I didn't really know it. So you've got to learn how to teach people how to ask the right transformational questions. This is an example of what I call the root questions. And this chart you probably haven't seen, but it's a chart used a lot in DoD or NASA or technology communities. And it says that as we take and develop technology, we start with an idea, TRL1. And you move it up to the point, TRL9, where we're trying to say it's operational, it's normal, it exists everywhere. The problem is that I think we're missing the point that there's what I call a root question, a question that actually drives the first idea. TRL1 starts with an idea. What we've got to realize, you got to teach people to ask the right question, not necessarily answer it because there's a lot of experts for that. The challenge we have is how do you create a process that taps these unknown resources, and it may be the subject matter experts or it may not, and pull those root questions. And then how do we push those root questions into this process? Yes.
Okay, so based on how you feel like you're pushing, thinking, so for a good question that I think would be best is, do you think that the educators now are not pushing for students to think more outside? Because they're getting an older generation and more just, more millennials?
That's a tough question because I've kind of put teachers against students. So the question is, are we actually doing a good job of teaching how to find root questions? I will say yes, but it's just not teachers and it's just not students. As a society, we don't ask the right root question. We become complacent. And at the most, we take that complacency and we make it a little better. So we do outside the box, not outside the future. So I think as a whole, whether it's a student, continuing learning, or in a company, we need to do a better job of having people teach or learn how to ask root questions. Okay. Yes? Okay. This is the second example, and unfortunately, I guess we do cut off some of the top. This is called solution-based research. And it's the idea that most research, I'll live with it. Most research happens because it's pushed forward. Somebody comes up with a great idea for technology. Somebody says, okay, I can make something better. And usually what happens is you conceptualize it, and then you take and you push it up into a prototype or a proof of concept. And this is a chart that I created a while back. It's that basic research into applied research. But in reality, I'll argue that a lot of the technology we do in today's world comes because we're trying to solve a solution. The question is, how far in the future is that solution that you're looking for? And that solution may be what we have a solution of the future, and we have the push of a root question. And the real goal is how do you sequence those to get from one to the other? And we need to teach how to do that. It's a hint, so I thought it doesn't work now.
I didn't go.
I don't either.
Dr. Davis, official,
I don't need for it to go away. I'll talk around it. I just need for the chart to move.
Right now.
Yeah. Okay. So
open the chat. Okay, close the chat.
He's demonstrating what I was thinking earlier. Is if I want to get an answer, ask a young person. All he did was prove it for me. I'm not calling you old though. Aha. You thought it was, yeah. It's all right. I'll make it work. So what I want to, yeah, now I can't get down again. Actually, I can't move at all. I did. Yeah, that was the problem. Let's try enter. Nope. Yeah. Nope. Ah. Okay. You know, I'll live with the top being blank. That's fine. So what I want to talk about is a couple things that need to be learned. Is kind of what I'm at. The first one I'll call paradigm shift, and I don't know how many people have heard of paradigm shifts, but a paradigm shift is basically when we make a drastic change. Now, it's called an inflection point. And it's the idea of how do we change the pattern of thinking? You know, paradigms are things like assumptions, your concepts, its values, its practices. It's these things that we use to build our life and our work around it. What happens is there's a lot of what's called paradigm paralysis. Now, paradigm paralysis happens because people just basically refuse to see beyond the current model of thinking. In other words, they're not thinking outside the future, is what I'm going to tell you. And thinking outside the future is making people recognize that this paradigm paralysis that exists and how we overcome that. The second thing, and again, the mouse not working. Making a challenge. Let's say that. They're not working. I'll live with what's it called. There we go. Okay. The second thing I'm going to teach is what's called punctuated equilibrium. And this comes about in a lot of areas, but one of the ones that's been most demonstrated in the biological area, which is that change doesn't happen in a linear fashion. Usually change happens in a step function, and that's punctuated equilibrium. And we need to understand how we can change that, how we can create that punctuated equilibrium by asking people who really are not subject matter experts. I'm going to tell you most punctuated equilibrium comes from not the person expert in the area, but from somebody else. The problem is, and you'll see the word at the bottom, is the stickiness of punctuated equilibrium. Stickiness is back kind of like paradigm paralysis. Is how do we teach that the world doesn't really want to change, you know, and how do we take our thoughts and our ideas and introduce them in a way that can make a change? And I don't mean being abrupt or abusive or anything like that. I mean, it's just sharing your root ideas along the way. And this is called visualizing strategies, and I'll give you a couple of examples. One of these is lateral thinking, is what we need to teach. And some people call it cross-domain knowledge. And I've lived a whole career of this one. And it's the idea of how does ideas in one area affect another area. And one of the best examples I have is when I went to work for NASA. If you remember the Apollo program, and they had the large track device that carried the rocket out to the pad. Trouble is, it tore up all the stones on the way out. And at first, they couldn't figure out how to level this thing out. You know, they tried to engineer it. How do they level out the ground this track device was carrying the rocket? Well, somebody in the crowd evidently said, you know, I'm from a farming background. And we have what's called a harrow. And we use the harrow to level the ground. And they took that harrow idea, went out, put a harrow, and they leveled the ground. So cross-domain was taking something from farming and actually using it in the space program in order to proceed. That's cross-domain knowledge. The second one is transformational insight. That is looking forward. And you can read all the words, by the way. I think you've already noticed I don't read everything. The idea is, how do you create an environment where vaguely defined descriptions of the presently unimaginable events happen. And the real secret to this is you got to put them in a world where the current rules for technology, science, for operations doesn't exist. My best example for this is I used to have a team of project managers at NASA, 28 of them, and their goal, in fact, they weren't too much older than you, really. The primary goal of those individuals was to think of the missions of the future, way out. One of the examples is the replacement of the James Webb Telescope. And we're talking back in the 90s that they were thinking of something that didn't happen until a lot later. So how do you get these people to think about this? But there was a group at NASA who taught, how do you think transformational insight? And what they would do, as an example, is they would bring together a team of engineers. And they would tell these engineers, okay, it's 75 years from now, and I'm going to fly to Saturn in 5 days. Engineer says, can't do it. Why can't you do it? Because you can't fly that fast. Why can't you fly that fast? Well, because I don't have an engine that pushes me that fast. Well, why not? Well, because I don't have this technology that does it. Well, why not? Well, if you notice, what was happening was they were in the future where they couldn't rely on their rules, their engineering practices, whatever it may be. And they tried to say, how can I make that vision of the future, 75 years in the future, happen? And they did what effectively became, I would call, reverse innovation. That is, they carried it back to the point where they realized what they had to do today in order to change the future 75 years from now. And they created those root questions, is what it came down to. Sequence mapping at the bottom, oops, excuse me, now portion. Sequence mapping at the bottom is actually taking what I showed earlier. It's the idea that we want to grab these root questions and we want to understand solutions in the future. So far in the future, many people can't realize it. And you want to take a roadmap to get from here to there. You want to define a path along the way. That's sequence mapping. Now, by the way, these are just a couple examples of visualization strategies. But that's what needs to happen is we need to learn, teach, however you want to label it. And I'm trying to tell you it's more than just in an academic environment, how to do this kind of visualization. This one says cross-domain learning. I've already given you the example, but what I want to key is how important it is for this cross-domain learning. That gives an example towards the end of it. If you're into the science side, Maxwell took fluid dynamics and created electromagnetism of it. Took one area and created another entire area. But the real question is, how do you make this happen? And I argue that the best people to make a change are the people that aren't the experts in the area. And I'm going to give you a great example that probably doesn't make me look very good. I have a workshop. Workshop was very large, 20 by 12, built furniture, things like this. My wife does sewing, and she spends a lot of time doing crafts and things. And I'm down in the workshop, and I'm building something. And she comes down and she says, why are you doing it that way? I said, because that's the way it's done. You do it through this type of process, practice, whatever you want to do, design. And I go, that's just it. She walks away. So about half an hour later, I go up and I say, you were right. Because she could visualize something that I couldn't, because I was so entrenched. In fact, you'll find some of the people that have won the Nobel Prize, especially in science, do it very early in life before they're biased and before they don't realize they can't do it. And that's what we need to teach. Let's talk about how do we make this all happen? How do we, learn? This says outside the future community, by the way, if you can't read the title. But the challenge is, how do you create this community, these groups of people that really tries to change the future, to visualize thinking outside the future? The goal is we want to get those thoughts from those people, and most people are very uncomfortable with sharing ideas that they think might be wrong. It's very difficult. But what I argue is you've got to create an environment where that happens. In fact, that's the second one, is if people perceive that they're going to be deemed as incompetent or just uninformed, they're not going to share. And you got to teach how to build a community of these kinds of people that really share the crazy ideas. And I'll tell you that from my work in NASA, I've been in those kind of environments. Both, actually. Ones where they said it can't be done because that's not the way it's done. And I've also been in environments that says, why can't you do it? You know, and we need to create more environments where, why can't you do it? And we need to create the environments where they share this knowledge, where they bring it together. And in a sense, that sequence mapping that I mentioned before, the transformational visualization, the cross-domain knowledge is all driven by this idea of how do we share it? And we come up with those root questions that we push into thinking outside the future. The next thing is the environment itself. I'm looking not because I don't know the words, I just want to make sure. The first thing is we need to take those creative ideas and we need to bring them together. We need to come up with that solution, that vision that we're looking at in the future. What is possible? We need to make sure that we are allowed to say non-nonsense, or we have nonsense type ideas. You know, I used to work a lot with scientists. We'd travel overseas. I'd be sitting somewhere in France or somewhere talking to these scientists who are building the instruments. And I'd say, let me ask a stupid question. That was actually a phrase that I tend to use a lot because, you know, I recognized the fact I didn't know what the heck they were doing. But what I did find out is this nonsense type question became very important many times. And it was something they hadn't thought about. But I was trying to, let's say, lower their defenses by trying to tell them what to do rather than asking why not and things like this. And we need to create an environment where we can, visualize these vectors forward. You know, the transformational visualization was one of those kinds of examples. But again, we just need to create this kind of environment. So reimagining, this says foundational thinking for reimagining the future, for thinking outside the future. It's the first light questions. Those are the ones that I just talked about, the root question. We've got to enable people to think in teams of these root questions. We need to do those visualization strategies. We need to do the cross-domain thinking. And this is just a repeat of what I said earlier. But the real question is, why do I call it first light questions? Well, one of the missions I was on, as I said, was looking back 13.5 billion years. And what we were doing is we had a telescope that at some point, approximately, well, this is 14 billion, but at 13.5 billion years, all of a sudden we saw the first light that changed the future. That's my reason for first light questions. Another one is in NASA, we built satellites with telescopes, and we would launch the telescope, and the telescope has a door on it, and the door is protected for environmental reasons. And at some point, we opened the door, we figured it's safe, and they see the first light of what we're trying to see. And that's why I have first light questions, just a side comment. So what I propose is we need to create a system, I'll call it a learning system, that creates this discontinuous, disruptive innovation vectors. Now, these vectors need to be so they can be actionable. And what I mean is, as I told you, we asked the engineers, why can't I do this? And we backed up, and we backed up, and we backed up to a technology. But at the end of the day, it was actionable because they knew they had to go and take a certain action in order to create that first step of changing the future. The other thing was making sure that we're solving things that haven't even been thought of. I do a lot of work with unrealized ideas. The hard part is if you can think of it, you've probably realized it. But if you put together the right groups of people, you can actually start imagining the future. Remember my comment earlier about return on imagination? It's the idea of how do you get people to dream, but turn those dreams into reality, because we all have that potential. The other thing is that we can create trends. We need to show that we can take these root questions, we can take these visions of the future, and we can build a map and show how you build these maps. You know, teach that we can envision the future by these steps along the way. By the way, I'm a project manager primarily by trade, so I worry about things like schedules and timelines. So that's probably why that comes out. But what we need to do is we need to seek those alternative futures versus solving specific solutions. That's why SMEs are great, because they solve a specific solution. But I'm not talking here about solving a specific solution, which is critical and important. What I'm talking about is how do we solve something we don't even know about. In NASA, in many places, and some of you may have heard this, there's what's called the known, which you know is going to happen or not happen or trouble. The unknown, which is you kind of know something might happen, but you don't know what it is. And then there's the unknown unknown. And the unknown unknown is really things that just catch you totally by surprise. You have no concept that it was ever going to happen. You couldn't do anything to protect yourself. Well, in a sense, what we're looking for is the unknown thoughts of the future, if you want to look at it that way. What we want to do is we want to change the boundary. I sometimes find myself frustrated with, trying to think outside the box. We're not really changing the future. We're just improving the present, is my mindset. So I argue that we should be changing the future and rather than just changing the boundary. We need to understand that paradigm paralysis exists. Now, this comes in a lot of flavors. It's punctuated equilibrium, it's paradigm paralysis. But just because it is the way it is today, doesn't mean that you can't suggest changes. And my argument is that we need to be teaching how we introduce those changes. I had a conversation a couple of weeks ago. I worked at Disney for a couple of years too, by the way. And I was talking with a director there that I had. And I asked him what's missing from students or anybody really who comes to work. One of those was problem solving. One was reasoning. But one of the ones was, how do I present an idea? What he found out was we don't know how to present ideas about what we think about. So not only do we have to have the idea, but we have to learn how to share those ideas. And that needs to be taught in reality. In the end, what we need to do is build this system so that we can change those paradigms, those mindsets, change the future along the way. For me, thinking outside the future means root questions. It means visualizing the future. It means teaming ideas. It's all of the above. I think that's, let me see. Yes, by the way. Oh, good. You can read the quote at the top. And that's Einstein. Should say it there somewhere. Yeah. But for me, we need to learn, we need to teach thinking outside the future as a normal practice. It's just not fun and cool, but it's critical when you go into the workforce, when you're part of any group or team. Thinking outside the future is a skill set that needs to happen all the time. That's kind of the end of the presentation, but I'm going to take questions at this point. Let me guess. You got a question.
So, taking, I'm trying to think of a question.
You are. How about somebody else? I'd say online, but we can't see the online.
Do you think that thinking outside of the future is going to push the present further than it would be just trying to improve the present?
Is there any online questions?
Not yet, but someone asked you a question.
Okay. There's your answer. Basically, you can live in the present and it'll work, but I'm going to tell you, you're going to get surprised. If I would have thought of things that exist in this world when I was your age, a few years ago, would have never envisioned. And if I would have built, there are people that, well, let me give you my wife as an example. She went to college and did exceptionally well getting a degree in home economics. I challenge you to find a college or a university today that has a degree in home economics. But it was the thing. And she was very good at it along the way. So you got to be careful. I say, you got to be careful that what you think is the future, you've got to train yourself to think about what it could be. Maybe that's too heavy. More questions. I really do appreciate questions, by the way. Don't they give extra credit?
Yes.
I have one, but I don't, once I start talking, I might not stop. So I don't want to start unless, if there are other people who have questions.
Program. How do some of your concepts work when it comes to anatomy and physiology?
That's a hard question for me, not the
Right.
question.
Right.
So thinking outside the future is true no matter what discipline you're in. And what you need to learn is, and I've kind of learned this from my sister-in-law, who's a nurse. Actually, she's a nurse in ER. And she didn't start that way. She didn't become a nurse in ER until she was like in her 40s. But she learned that even the future, what the doctors may perceive we need to be doing, there's nothing wrong with questioning it. And questioning what could happen in the future and learning. So I would say that what they need to learn is just because they have certain skills and practices isn't necessarily what's guaranteed it's going to be in the future and how it's going to be done. And in fact, I will go further and say that I'll say the right environments being where people can hear and listen and absorb what somebody's trying to share, you can change it. And don't be afraid to share it. The hard part is, as I mentioned, the weakness in our environment is how to share that information. The presentation of an idea, the sharing of an idea, without creating a defensive environment or without creating an environment where it's not heard because it's not done. Okay. Dr. Hayward, did we have a question online?
You may have gotten knocked offline.
Yeah. I don't see, I'm still online. I don't see any questions in the chat.
Good. And that's fine. I tend to find that most of the times I've presented these ideas, it's something people hadn't thought of, ironically. Thinking outside the future.
So do you, on a daily basis, think about it? Like,
Yeah, unfortunately. I'll tell you what I think is, and now to the side, but not, is I collect a lot of information in my head, and they're just dots. They're bubbles in my brain. And what I tend to find is that somewhere along the way, my mind grabs those bubbles and connects them, and it becomes the unrealized future.
sometimes you perceive that the questions based off of other information that you learn.
Yeah, that's how honest I am with myself as a question. Yes.
Albert, can you hear me?
Yes, Ben.
Yeah.
Just put it in the chat, please.
So I have a question. It's more than a question, but I'll start talking and Albert can shut me up if I talk.
Well, then he can't hear you in the room. He can because I have everything muted. You just tell me.
So we can hear everything now.
Hold on, give me your question. Hold on a second.
That's a long question.
Hold on a second.
Go ahead.
Can you hear me?
I can.
So I really enjoyed the talk, and interestingly, or no pun intended, it raised a lot of interesting questions in my mind. Uh, first, first, it reminded me of a quote of Picasso, supposedly, when he was asked if he thought computers were interesting, and he said no, because the only thing they could give you was answers. Um, I agree with you that we need what I would refer to as mental frameworks that change the way our students think. Now, an example of a paradigm shifting mental framework for the biological sciences in education today is the metaphor of biological systems as computational systems. So if we start giving students these forward-leaning mental frameworks to support a new way of looking at something like the biological systems, in addition to these paradigm shifting frameworks, we need to look for things like symbolic representations that can serve as agents of transfer to support these new ways of thinking that we're trying to give students. So these mental frameworks, these symbolic representations can serve as a way of guiding metacognitive questions to guide in a more it's 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 more open-ended and advanced than they would be able to reach otherwise, but it's still within a framework that's opening their mind. But it's also something that is, I forget the term that you use, but I would use it. It's within their reach. It's more than the previous out of the box thinking. But it's enough to get them started on thinking beyond the way they previously thought. Maybe the thing that I should do is just ask you to respond to that as a very similar but slightly different way of looking at this from what you were talking about.
Yeah, I'm trying to think of the right thing. I think you can hear me over here too, right?
I can hear you well.
So so what I'm hearing is, well, I'm not totally sure, but how do we build a structure to enable this kind of thinking? Is perhaps the way I would look at it. And what my first response is going to be, he said, to teach students, and I'm going to tell you it's to teach anybody. It's not restricted to students. The continuing education in a company, doing training, whatever it may be. But the structure is, how do you teach people not to be afraid to share ideas that may be perceived as bias, that may be perceived, and when I say bias, you're an engineer, there's a certain way you build something, and you use certain technologies to accomplish it. And there tend to be bias, and what you do is you introduce a new idea, and totally things change. You need to create environment. You need to teach that you need to be a part of enabling that environment of free thinking. And that's really what we're trying to teach as a structure. Free thinking that is not restrictive, in my mind. Now, again, everything I'm speaking from is lessons learned from my career and my life, and watching how we built things that changed the world. And what happened every time was we had to build a structure where people were allowed to think outside the future, is what it came down to. I would have to think a little bit more about what the specifics would be. My idea is it's visualization technology, it's teaching cross-domain knowledge is important, things of that nature. I don't know that I answered it, but that's how I feel the response would be.
Certainly it would be possible to have a conversation that we have time for today within this meeting, but it was interesting. It was interesting listening. Thank you.
Thank you. Thank you.
All right. Thank you so much, Tom, for that. We really appreciate your insights. We plan on having you back at more time for some more discussion. Very limited. Thank you all for attending our lecture series. This is a continuing series. It will continue into the next semester. If you missed any of the previous lectures, they are all on our website. This is a shameless plug. It is the HBCU Science and Learning Network. It's in all the links. You should be able to link directly to that, to the website. All of the previous lectures are recorded. They are on YouTube, and they are also linked there through the website, along with our journal clubs. If you are interested in joining the Science of Learning Network, there is an interest form at the bottom of that page as well. Please just fill it out, and one of the team will be in contact with you very soon. We will be continuing our journal club series as well. And those of you who are interested in being a part of the Science of Learning Network, we will be going to Learn Lab this summer to attend the Carnegie Mellon Learn Lab Summer School to help continue our understanding of the science of learning and work some with the gentleman you heard, Ben McWarner, to develop some tools that we can use in our classrooms to help drive learning. Thank you, students, for participating. This is for you to understand as well as for faculty, so you can understand the concept of learning. Right?
I'll reinforce that. You teach me more than I teach you. No, I've found that in the past.
So, thank you all so much for attending. We really appreciate it.
Thank you.
Everyone on Zoom, thank you all so much for attending as well. Once again, if you are interested in participating in the Science and Learning Network, please reach out via the interest form, or you can email me, Dr. Butts, on the HBCU-SOLN at gmail.com, that email, and we'll get in touch with you as soon as possible. Thank you.